Hello, welcome to our YouTube channel where we are providing mathematics to people that are writing their grade 12 exam. And in this lesson, I'm continuing to look at mensuration, and under mensuration, I'm going to present to you a lesson on how we calculate the total surface area of a pyramid. The total surface area of a pyramid. Now, we have two examples of pyramids here. This is a square-based pyramid, and then this one is a rectangular-based pyramid. So I'm going to take you through these two to demonstrate what we are supposed to do in order to get the total surface area. So the total surface area, what are we talking about? We need to, the total surface area of a pyramid is found by adding the area of what? The triangles. The triangles. So as you can see, each of these pyramids has got how many triangles? 4. Each of them has got 4 triangles. So we need to find the area of each of these triangles. Then we add them together, plus the area of the base. I tried to come up with a model of what I'm talking about. This is the first one. Okay? This is the first one because we're saying the square, the base is squared. So, as you can see, I've tried to make something that has got a squared base. So, this is a pyramid as per the first one. And it has got how many triangles? 1, 2, 3, 4. So, that is what we are trying to do. So, I'll be referring to these things so that we have a practical case. Okay, so this is the first one. The second one, although it's smaller, this is a rectangular, where the base is a rectangle. The base is a rectangle. So it's a pyramid also. We've got how many triangles? 4 triangles. We've got this triangle, this one, and the. So what we are supposed to do to find the total surface area of this pyramid, we are supposed to find the areas of all these 4 triangles and the base, which is a rectangle. Then we add together. That is going to give us the total surface area of this pyramid. And as you can see, if I'm talking about this one, this triangle here is the same as this one. And these two also are the same. So when you find the area of this one, you can multiply by 2 because you know it's the same as the area of the other one. It's the same thing. Even this one is equal to this other one. So when you find the area of one, you will be able to know the area of the other. But for the first one, all the triangles here are equal. So all of them, the 4 of them, why? The square is, the base is squared here. The base is squared. So even our triangles are equal. So once we find the area of one triangle, we can multiply by 4 to get the total surface area of these triangles. So the total surface area of the triangles, we have got how many triangles here? 4 triangles. And if we want to find the total surface area of the pyramid, we need to find the area of all these 4 triangles plus the area of the base. Okay? That is very important. So, allow me to... So what are we saying? We need, yes, that's what I've explained here. Then the formula for calculating total surface area of a pyramid varies according to the shape of the base of the pyramid. As you can see, these 2 pyramids have got 2 different bases. So it is the base that determines how you are going to work with the calculations. Sometimes we can also have a pyramid that has got a 3-sided base. Okay, you've got, this is a pyramid here. So you need to find the area of, in this case, we're going to have how many triangles? 3 triangles. You're going to have so you find the area of the 3 triangles plus the area at the base. The area of the base, which is also a triangle. Okay? So In this, I'll confine myself mainly to these two here. So, I hope you have gotten what I explained. Now we can begin to look at the process and what we are supposed to do. Okay. So, what are we supposed to do? We're saying we need to find the area of, or the area of the what? The four triangles. Each of these four triangles and the area of the base. Then we add them together. Now, please pay attention. So, from this, okay, from this, I'm going to have it open like this. Okay? I'm going to have it open like this. I hope it's clear. I'm going to have it open like this. You've seen, this is where this one came from. Now I've opened it, and this is a net. We call this a net of a square-based pyramid. Okay? I hope you are going to follow me. So now, what we are supposed to do is to find the area of these four triangles and the area of the base. Then we add together. It's as simple as that. Now, please follow me. In this case, we need to find the area of if you look at this part here, I don't want you to confuse. Let me go back. You've seen this part here, which is this one, this line here on top. It is this edge. Okay? It is this edge here. It is this edge. But then the 12, it is the slant height, which is the middle part of this. The middle part of this. That is where our 12 is. And then we have the edge here. This. So when we talk about the slant height in this case, when we talk about the slant height, we are referring to this height from this point up to the top, or even this side. From this point, this. Okay. Now I want you to follow me. When we open this one, get what I'm saying? To find the area of a triangle, what we need is the slant height, like this middle height here, which is going to give us, that is what is going to be our height. This is not what we are going to use. Now, look at this. Our 12 is here, and then this edge is here. So if you've got a measurement on this edge here, or you have got a measurement on this edge, when you open it, that measurement which we got is going to be along this line. But the measurement that we need to calculate the area of a triangle, it's this middle one. It's this middle one. Okay? Now, in this case, for the first one, it's straightforward. What we are given, we have this case here. And we are saying this, the base is squared. The base is what? The base is squared. The base is squared here. The base is squared. So meaning we have the base is squared, and this squared base, it's what? It's 8. So if we are saying it's squared, even the other side here, it's 8. Okay? Even this side, it's 8. We may not need to indicate because we're saying this is squared. I hope you are following. Then we want to spread now. So this part, it is going to come here. And now you've seen this is what we are given as 12. Our 12 is here. Make sure, please take note. 12 is not this part here. When you open it, it becomes this. Then we also have another triangle here. Then we have another triangle here. And another one. The last one. So the total surface area, please, I hope you are following me. The total surface area of this pyramid, the total surface area of this pyramid, we need to have it. The question can be given either this way, or it can be given as a net, or they can have it like this. But like what you're supposed to know is what I'm explaining there. To find the total surface area of a pyramid, you just need to find the area of the base and the area of these triangles. Now for the area of the triangles, this is what I'm explaining. You need this height here. In case it's not given, you need to find this. Sometimes it's not given. Okay. So in this case, we are given the same height that we want. So I'm going to start with the area. I'm going to start with the area of the base. The area of the base is a square. The base is a square. So we are going to multiply 8 by 8. 8 centimeters multiplied by 8 centimeters. This is going to give us 64 centimeters squared. I hope you are getting me. I hope that is very clear. Then, when we come to the triangles, I did indicate that in this case, since our base is a square, and from 1 to even these triangles, as you can see, they are the same. They are the same. So meaning, when we find the area of one triangle, we'd know that even this one has the same area, even this one. So when we find the area of one triangle, we multiply by 4 because we've got how many triangles? There are 4. I hope you're getting what I'm saying. So, you know that, let me get this triangle here. Maybe we are used to seeing triangles in this manner. This is our 12, then the base. Get to know that this distance from here up to this point, it's what? It's 8. And the area of a triangle, right angle triangle there, you know that the area of triangles, or maybe if you want I can say triangles, because there are 4. It is going to be 4 multiplied by 1 over 2. 4 in the sense that we have 4 triangles and the area that we're going to get is the same. So now this is our base and this is our height. So we are going to say 4, because there are 4, 1 over, which is, or if you want, because here we have got 4 and we've got 2, I can divide here so that this becomes 2, but let's leave it like that. So this multiplied by the base is what? Our 8, multiplied by the height. What height do we have? The height here, okay, it's 12. So when you simplify this one, we have 4 multiplied by 4, 2 into 8, it's 4, then multiplied by 12. What are we getting? 16 multiplied by 12. Okay, so 16 multiplied by 12, what are we getting? 12 multiplied by 16. We are getting 192 centimeters squared. Okay, centimeters squared. Okay, so this is the total surface area of the triangles. This one, it's the total surface area of the triangles. Then 64 is the surface area of the base. Now, we are saying to find the total surface area of the pyramid. We need to find the area of the base and the area of this triangle. So our answer is going to be the total surface area of the pyramid. We have the total surface area of the triangles. That is not what we want. You want the total surface area of the pyramid. Or I say total surface area of the pyramid. Total surface area of the pyramid, we are going to get 64 plus 192 squared. What are we going to get? (192) plus 64. We are getting 257. 6 centimeters squared. This is what we are going to get. This is our total surface area for the first one. This is our total surface area for the first one. Whether it is given in this form, whether it is given as a net, this is what you are supposed to do. I hope that is very clear. I hope that is very clear. All right? So we can proceed to the next example. We can proceed to the next example. Okay. So the next example, I will refer you to this one. We are saying, and the next example, we are saying the base, it's a rectangle, meaning the measurement, as you can see here, we've got 6, the other side we've got 3, which could be another measurement. If it's a rectangle, it means it's not squared. The measurements here, the length and the width are different. So now, then what we are given, please take note of this. What we are given in this case is the perpendicular height of this, it's the perpendicular height of this what? Pyramid. That is what we are given in this question. That is what we are given in this question. So what is this perpendicular height? It's this one that comes from the center here up to the upper part here. Okay? This one here, the one that comes from the center, from this point up to that. So that is the height that we are given in the question. But to find the, I'm opening it, to find the area of these triangles, we don't need this perpendicular height, which I said, it is standing right at the center of this and coming out like this. Okay? That is not what we want. What we want is the height, the slant height of these triangles. The slant height of these triangles. Are we together? We want the slant height of these triangles here. We want the slant height of these triangles. That is what we want. If the slant height is given here, if the slant heights are given this side and this side, that is, the question is very simple. But in this case, what we are given is the perpendicular height of the what? Of the pyramid. So we need now to find the these, you know, the height that what we want ourselves. It's this one. This is what we need. Now it's not given here. Instead, we are given this height that stands right at the center here. So now, the process that we are supposed to do, you know that the height that we are given, it's this one. This height that is right at the center here. But as the height that we want, it's this height here. You understand? So we are going to come up with a right angled triangle. We have this height here, which is given, and the height that we want, it's this, the slant height. So we are going to work that out. Please follow me. If we open this one out, well, we open it, it's going to be like this. Then, what we need in this case, because these triangles are different, this one is equal to this one is equal to this one. Now we need to work it out like I'm going to demonstrate. Okay? This triangle is equal to this one, and also these two are equal to each other. So now, what are we given here? This is 6 centimeters, and then this is 3 centimeters here. So take note, but then we are given this height here. But what do we want? We want this one. Please follow me. This is what we want, to find the area of this triangle. So what I'm going to do now, I'm going to have a right angle triangle. This one. This perpendicular height, it is this one that we are given at the center here. This one, where it meets with this one. So what is this one? This one is given as 10. It's given in the question. Okay? Then H, where is H here? H is the slanting height here. H is this part that is slanting. So H is this one. Okay? That is our slanting height. Or maybe let me use the letter L here. Okay? Like, this is our slanting height. This is what we want. Please take note. We want the height here. Now, when we fold it, it slants like this one. And then please help me find this one here. Okay? Look at what has happened. What am I dealing with? I'm dealing with this part. So we want the distance from this point up to the center here. The center where we have this 10 centimeters up. Okay? So we are looking at what is the distance from this point up to this one. So we are going to use this part. It's half of this one. So it is 1.5. It is 1.5, which is half of what? Half of 3. Then at this point now, we need to find this one using Pythagoras theorem. Using Pythagoras theorem. So we need to understand what Pythagoras theorem is, and I used it in the previous lessons, if you remember, when we were looking at volume of a cone as well as total surface area of a cone. I still applied this concept. Mathematics has a lot of intertwined concepts. So here we are borrowing from another topic. So you remember, you recall from those lessons that I'm talking about that to find the slant height here, we are going to find the square root of 10 squared plus 1.5 squared. Okay? What we want is this one. Please get what I'm doing. So we say the square, we can work this out. The square of 10 plus the square, okay? So for me, what I'm getting this as 10.1111. That's what I'm getting. 10.11, I mean 10.11. 10.11. 10.11. So now, you know now that this is 10.11. I've rounded it off to 2 decimal places. Are we together? Then, after that, this one, we can say L1 is equals to what? We call this L1. Is equals to 10.11. I've rounded it off. I don't know if you are able to see it. Okay? That's what I'm getting. So, then, we remember, we also need this height here for the other, because these triangles are different. This one, the way we have worked out for this one, we know that we are going to use the same slant height even for this one. Now, these two are also different, so we need to work out this one. Now, in this case, what are we dealing with? We are saying we have our case like this. Now we are folding this one here. Take note, we have our 10 centimeters here, which is at the center, which is at the center. Then we have, this one is the one that we are folding now, okay? So it's like the 10 remains, now we need this one, which is L2. Then, what is this? How do we get, now we need, take note, from this point here, okay? From this point here, we have folded this one. And we also need this distance here. The distance from this point up to that. This distance. This is what is going to be this distance here. Okay? This is what this distance is going to be. If you want, maybe we do it like this. Our 10 is this one. Then we have this point that we're going to fold. It will be this one here. Then what is this distance from this point up that one? We are using this one now. So it becomes half of 6, which will be 3. Okay? Which will be 3. So now we can use the same formula also, where we'll say square plus, what do we get? That's what we're going to have. Okay? Then the other one here, I'm getting 10.144. That's what I'm getting. Okay? 10.144. Please, I hope you have followed what I'm doing and you're writing this work down. Okay? So, now this is 10.11. Okay? Or maybe I can put it this side because they are the same. This is 10.11. Then this other one here is 10.44. It's the same as for this one. So now we go back to finding the total surface area of the pyramid. The total surface area of the pyramid that has a rectangular base, like what I've done here. So I'll start with the area of the base, or area of the base Our base is a rectangle. Our base is a rectangle, which is, this is 3 and this is 6. So we multiply 3 multiplied by 6. What do we get? 18 centimeters squared. Okay? Then I can come to this one. I know that when I find the area for this one, it's the same as the area for this one. These two triangles have the same area. So I'm going to say now, remember we have this one, then the second one is going to be 1 over 2 BH multiplied by 2. So this is going to be 1 over 2 multiplied by, remember if we are dealing with this one, our base, this is also 6 here. So our base is what? 6 multiplied by the height there is 10.11 multiplied by 2. Why are we multiplying by this 2? We also want to find the area for this one because these triangles are 2. So I can say 3 multiplied by 10.11 multiplied by 2. This divided it into 6, get 3. So we multiply now. These ones that we have here. So we have 6 multiplied by 10.11. So this is giving me 60.66 centimeters squared. So we have this one. This is for these two. Then we come to the other two. So we are going to do the same process. 1 over 2 BH multiplied by 2, because we have also two similar or they are the same. So we have 1 over 2 multiplied by, this is as good as us saying these 2 and these 2 cancel. So we have our base. Remember, for this one, the base is what? 3. Then we have 10.44. 4. Don't make a mistake. So the base that we're going to use is what? So we have 1 over 2 multiplied by, our base is 3, multiplied by 10.44 multiplied by 2. Okay? So we also multiply this one, which is as good as 3 multiplied by 10.44. This is going to give me what? 31.32. Then I'm adding, okay. Then now to find the total surface area of the pyramid, we need to add the area of the base, which is what? 18, plus the area of these two triangles here, which is what? 60.66, plus the area of these other two triangles, which is 31.32. And please make sure that these things, before you also do it to confirm if you're getting the same things. So the total that I'm getting is 109.98. Okay? Centimeters squared. If you have to write this to 3 significant figures, it's going to be 1, 0. Oh, when you add to this one, you end up having this. Okay? So maybe it will end like this. Okay? So basically, this is what I felt that I needed to explain. Make sure you redo these examples over and over. I don't think there's an aspect that I've left, except the other one that I can also just tell you, run you through, just in case you are given such. Just in case you are given such. Okay? What are you supposed to do? I mean, that is maybe also what I may need to explain to you. Just. Okay? So, what if you have something? You have either it's a rectangular based, it's given like this. This is given as 2, this one is given as 5. Then okay. Now look at this. Under, like I've already explained, that to find the total surface area, what we need is the slant height. The middle height, this height here is what we need. Now, if you have been given this one, suppose this is what has been given. Suppose this is what has been given. Or here, if we say this is 6 centimeters. This 6 centimeters, where is it? It's on the edge here. This is the 6 centimeters. And we do not want this one. So it is like now the 6 that I'm talking about is going to be here. Are we together? It's going to be here. So now you are going to use this 6 to find, our slant height. Our slant height is this part. This height here that is slanting, the height is what we want. Now remember that here is going to have this. Okay? You're going to have a triangle like this. You have 6, and then you've got 1, and then here our slanting height is coming this side now. Our slanting height is coming this side. It's perpendicular in this case. This is our slanting height. Slanting in the sense that when we fold this one, this one is folded, it's slanting. So don't look at it as it appears here. Imagine, okay, let's take this is the same one. What happens when it's folded? This becomes a slanting, the slanting height. You understand? This is the one that we want. So you calculate. In this case now you know how you are going to work it out. It's Pythagoras theorem. Now you have the hypotenuse. Okay? So instead of adding like we are doing there, In this case, it will be 6 squared minus 1 squared. You have 36 minus 1. The square root of 35. What did you get? That is what is going to be here now. That's what you're going to use. So you should look at it. I've tried to examine all the parts where you're given the perpendicular height and that. That is what you should be able to work with when we're talking about the total surface area. If they ask you, the question is asking you to find just the total surface area of the triangles. It's just the triangles, of course, without this one. We need just to make sure you read the question and understand it. Otherwise, this is what I felt I should present to you. And surface area of a pyramid. All right. So I'm going to give you questions for exercise, as usual. So make sure that you do these questions. I'll give you quite a number of them. But for those of you that do submit your work, maybe the first two are enough. Okay? Pause. So look at this question. This is the first question that I want you to do. It's talking about calculating the total surface area of the pyramid. Let's do this question. This is the first one. Read this question, also understand it. You look at it, saying calculate the total surface area of the triangular faces of the pyramid. It just wants the total surface area of what? The triangular faces. So also do this one. So please here concentrate on just this one. The same one here. This is a pyramid. Okay. Do the exactly like the first one that we did. It's calculating the total surface area. So look at question 6 also. Look at question 6. That's the question that I want you to do. Okay. I hope you have seen. It's the question of applying the Pythagoras theorem concept here also. Okay, question 6. That's what I want you to look at here. So look at this question here. So understand the question, and the only thing I want you to do is to calculate what? The total surface area of this pyramid. The total surface area of this pyramid. Okay, so there's also this example. Look at it. Do it. It's just an example here, which I didn't do. Do it, then see if you're going to get this answer here. See if you're going to get this answer. Then this exercise here has a number of questions that you can try. I said I'm giving as many as possible. Now, number 4 is interesting. It's very good for you to do. It's a very good question, number 4. Okay. So I think read this question. This is our last one. It's the same as the first example that we did. Okay? It's the same as the first example that we did. The same. So if you have this book, it can help you. This is grade 11 progress. There's also this one. All these books are very important. You can find something, even this one. Okay. So thank you very much.